Okay, Rolle's theorem is an extension of the MVT. Okay, so we understand that the MVT is where the slope of the tangent line is equal to the slope of the secant line. So Rolle's theorem, again, must state that the function f must be continuous, okay, condition number 1, on the closed interval from a to b. Condition number 2 is that this function must be differentiable on the open interval, okay, the same as the MVT. Here is the third piece that's really important. F of a must be equal to f of b. This is another way of writing y sub 1 must be equal to y sub 2. So if you think about when we would calculate a slope, we have x sub 1, y sub 1, and then x sub 2, y sub 2. If these two values are equal, meaning I have the point, let's say 3, 5, and 1, 5. If I were to calculate the slope at this of this line using these 2 points, you have 5 minus 5 over 3 minus 1. Doesn't really matter because you have 0 over 2. The slope is 0. If your two y values are equal, you will have a slope of the tangent, or excuse me, of the secant line that is 0. So what they're saying is that there is at least one point C on the interval such that the slope of the tangent line is equal to 0. That's what Rolle's theorem is. So it's where the slope is 0. So what they're saying here is that Rolle's theorem is a special case of the MVT, which is what I said at the top. Geometrically, it's stating that if your two y values are equal, then there's going to be some place on this closed interval where the slope of the tangent line is horizontal tangent line. In other words, the slope of the tangent line is equal to 0 at some given x value. So what we want to do is just set the slope of the tangent line equal to 0, because on this interval from a to b, the slope of your secant line, this green right here is the slope of the secant line. Slope of the secant line is clearly 0. Okay, so the extension of the MVT is that for Rolle's, the slope of the secant line must be equal to 0. So how do we apply this? Again, this is stated very similarly to example number 1 on page 24 in the notes. Verify the hypothesis, in this case, of Rolle's. So we're looking for the slope of the secant line is equal to 0. Okay? Now, the hypothesis will be stated the same, but there's a third piece to it. Okay? A third piece. So what we do is we state in the hypothesis. Okay? First of all, number 1. We have the sine of the half angle, okay? The function would be continuous. So think about the sine of x, whether it's a double angle or a half angle from pi. First of all, from 0 to 2 pi, sine is continuous. So is the function continuous on the closed interval? If we know the sine curve, yes, it is. So you would say f of x, you have to look at your function first, is continuous on the closed interval, and you're given the interval here, pi over 2 to 3 pi over 2. Okay, first part stated, it's up in the very top. Second part, again, we're looking at differentiability. Can we take the derivative of the sine? Okay, this is just a coefficient, so we could totally do it. It's not a problem. And remember, the derivative of the sine is cosine, and we would just have to take the derivative of the inside, which would be 1/2. It's not a big deal. So f of x is differentiable on the open interval. Okay, so now the last piece is that we have to prove, remember, this is x sub 1 and this is x sub 2. So we have to prove that the y values are equal. So in the third part for Rolle's, this I circled it because it's important that you do it for Rolle's. We're going to state that the y value for pi over 2 will be equal to the y value for 3 pi over 2. Okay, I can state that all I want, but I have to prove it, so you have to do the math. So what we're going to do is we're actually going to plug this into the function. Okay, so this is my x value. So we've got the sine of pi over 2 is equal to the sine of 3 pi over 2 over 2. Okay, guys, you got to be careful because this is a complex fraction, so you need to simplify. So remember, this is pi over 2 times 1/2. So we're evaluating the sine of pi over 4, and we want to make sure that it's equal to the sine of 3 pi over 4. Okay, this is in the first quadrant, this is in the second quadrant. Sine is positive in both quadrants. This is the square root of 2 over 2 is equal to the square root of 2 over 2. Okay, we proved that the y values were equal. So this is y sub 1 and this is y sub 2. Okay, so now that I have my hypothesis, I will go ahead and use the math for the conclusion. So my conclusion, okay, now remember what you probably have noticed for the MVT, there was no big statement. The math is my statement. Okay, your statement's really in the hypothesis. So we're going to find f prime of x. Okay, so remember we're going to use the chain rule here. So first of all, we would say, okay, what's the derivative of the sine of x over 2? It is the cosine of x over 2, and then we have to take the derivative of the inside, which is 1/2. Okay, so there's my derivative. So now I'm just going to use the variable c to differentiate, okay? And we're going to state that f prime of c, which is this right here is the slope of the tangent line, is going to be equal to the slope of the secant line, which would be 0, which we proved here, because my y values are the same. So when I plug them in to y sub 2 minus y sub 1 over x sub 2 minus x sub 1, I'm going to get a 0 in the numerator. It doesn't matter what's in the bottom, except for 0. Okay, so now we need to plug this in here. Okay, so instead of an x, I'll just use the variable c. It doesn't matter, you can use an x if you want. So I have 1/2 cosine of c over 2 is equal to 0. This is the derivative, or the equation for the slope of the tangent line. This is the slope of the secant line. Okay, so now I need to do the math. So I'm going to go up here and do the math. So I'm going to multiply by 2. Okay, so I end up with the cosine of c over 2 is equal to 0. Okay, I don't know where my half angle is 0, but I know, I'm going to do a little bit of work off to the side here, that the cosine of x is equal to 0 at pi over 2 up at the top and 3 pi over 2. Okay, so that's when x, if I plug these two angles in for x, this is what I'd get. Now I need to know what the half angle is. So what you do is you set the angle equal to what's in here, because this is no longer an x. So it's pi over 2 is equal to c over 2. Okay, I multiply, and I'm saying that if I have an angle of pi, okay, meaning my c value is pi over 2, cosine of pi over 2, it's 0, right? Okay, then 3 pi over 2 is equal to c over 2. Multiply by 2, I get c is equal to 3 pi. Okay, when I plug that back in here, it's a true statement, but there is a problem. This is not on the interval. You have to go back to your interval. My interval is from pi over 2 to 3 pi over 2. Pi is the only value that falls in there, so this is my answer. So you could say x is equal to pi or c is equal to pi. But this is Rolle's theorem. The only difference between MVT and the Rolle's theorem is that we're looking for the slope of the secant line to be 0, and the only way for that to happen is if the two y values for the corresponding x values from the interval are the same.